at it. Well, let's see, you guys sort of need to figure out what groups you want to be in. There are 5 batteries, so we've got, by my count, although it would appear,
Oh, Dana said she'll be late.
yeah, I've got a note from her to that effect. Well, there's a couple absent right now. They will be in. So I got 5 batteries, and really 5 stations, 27 people, so that's gonna be like 5 and 2 groups of 6. So for now, since 3 people are out right now, let's form into groups of 5. So there'll be, in fact, that'll work right now. We form into groups of 5, and then we'll just assign the 2 late ones to one of those groups when they get in. So we'll need groups of 5. When we talk about batteries and servicing batteries, first thing is, I don't know if Mark is lurking out there or not, but with respect to batteries, I will be lurking. You definitely want eye protection of some kind on. The little bitty splatters of acid. Actually, the dangerous thing about batteries is not that the acid is strong enough to do damage. It's not like you're going to be, I don't know, one of those CIS or CSI shows or something like that where the body's thrown into the boiling cauldron and it dissolves like piranha eating it really, really fast. It's actually the exact opposite. Is you get a little splatter somewhere and it's not strong enough to really do anything immediately. So you didn't really know it. In fact, it evaporates very quickly if it's, hits dry clothing. But it's still corrosive and it still dissolves stuff away. Now, it hits your eye, it's going to sting, but you may not realize it immediately. So, and the acid will continue to corrode. So, again, you get a little on your skin, and it may not hurt. And then after a little while, it sort of kind of hurts a little bit, and it's almost like you're getting a little rash. That's probably not good, is it? Man, it just went kablank, kaboof, and reset. It's dead in the door now. Cool. You're really going to want some eye protection. If you're doing any kind of regular work around batteries, you're going to want to get, a battery outfit, whether it's a battery apron, battery gloves, that kind of stuff. You're going to want to do that. Now, there are some general rules about working with acids or bases. It doesn't really matter whether it's an acid or a base. Both are equally caustic. In fact, you can do a far superior job of dissolving organic materials like human beings with caustic bases than you can with acids. The general rule is whatever is when you're mixing the two together, whatever is the nasty agent, pour it into the diluent, not the other way around. So if the diluent in this case is water, right? Said water mixed with sulfuric acid. If you've got a cauldron of, a thing of sulfuric acid sitting there or acid sitting there, and you pour water into it, start pouring water into it, first thing it's going to do is splash a little, right? Well, what's going to splash out is the acid, right? So, and it's going to be pretty concentrated at that point, as opposed to the other way around, where if you're pouring acid into the water, any splash occurs, you're going to be splashing out something quite a bit more diluted. Now, for our purposes, we're not going to be mixing water and acid. And in fact, it's been quite a while since we did that. I'm going to say 25 years, something like that, where on the automotive industry, it's been about 20 years, 20, maybe even longer, that they started getting rid of what we call maintenance-free batteries. You didn't get the acid separated at all. In aviation, we're still doing that quite a bit. But back in the early days, when I first started playing with them, you got a little bottle of concentrated acid along with, and well, you were supposed to come up with deionized or purified water and mix the two appropriately and pour it into the battery. Well, for at least the last 20, 25 years, what the battery manufacturer, if they sell you like the Gill batteries here, they'll sell you a battery, it's in a box, caps come off, and it's completely dry. Then next to it, they'll sell you get a second little box with a couple of quarts of already pre-mixed water acid. The reason they're doing that is because, and the auto manufacturers don't, the auto manufacturers know, or any battery manufacturer, let me say that differently, as soon as you pour the acid into the lead, or the electrolyte into the lead, your clock starts ticking. You've got about 5 to 6 years, period. Boom, that's it. After that, the battery's probably not going to be any good. In fact, the battery manufacturers, what they've said is, fine, since we know this is going to happen, we're just going to give you a 60-month warranty or a 36-month warranty if it's cheap or whatever it is, we're going to give it to you. And we expect we're going to lose a little bit of time on the, we make the battery, it sits on the shelf, it gets sent out to Dorman or Cragen or whoever, the local gas stations. By the time it actually gets put into service, it might be 3 or 4 months old already. So we've lost a little bit of time. The aviation industry, it doesn't turn over enough equipment for that to be viable. So that battery may sit on a shelf for a couple of years. By the time it leaves Gill, goes to a mid-level parts distributor, makes its way to Aircraft Spruce, makes its way, or Chief, or wherever, and then makes its way to you, gets put into service. It might be a year or more. So because of that, the industry still keeps the two separate. They are remarkably good at selling you just enough fluid. You will not be able to overfill the battery. And in fact, if you spill a little, you will have underfilled the battery. So you do want to be fairly careful whenever you're, initially starting up a battery. Get a decent little plastic funnel, and very carefully get all the fluid into all the cells. And what you really want to do is it comes in 2 quarts, just like a quart of oil. You pour in a little bit into each cell. Go through the first quart, go through most of the second quart, and maybe use the last quarter of the quart to balance each cell off. And you probably won't be right up at the ley line in the battery cell on any of the cells. That's okay. You've been given enough acid. You might be just a tad short on water. At this point, you don't really know because you're going to need. You don't need to charge it. It should already be charged. They may have you put it on a charger for a short period of time just to condition it and then put it into service. The battery cell, they don't give you a lot of wiggle room. So the cell sits here like that with the lid, and it has a hole cut in it that sort of comes down with a little ledge right there. The plates come up to about here. So the window for your electrolyte to be too high or too low is right about there. You want, and oftentimes what they'll do is, I don't know how to, well, let me draw just that. What they'll do is this will come down like this, and inside it'll have, it'll have a little marker ledge in it like that, and then maybe right here they'll cut just a little slot in there to let the bubble form up, but once you get to there, you can't go any further. Okay, if you try to pour any more in there, what happens is you'll get to right there, and then it'll just spew out the top. And they always need to leave a little bit of room for gas expansion and venting. Okay, that's too high. What you really want to do is at the very most, bring it right to where it's just starting to touch the lower end of the lip. Now what I find works reasonably well is it's a little difficult to pour it straight in unless you've got a decent funnel. If you have a relatively clean hydrometer though, it actually works to draw some water out of and again, distilled, purified water, draw it into the hydrometer, and then put the spigot of the hydrometer down in and put a little bit of the water back in. Once you've charged the battery with the electrolyte and it's in service, don't ever add any more electrolyte. The only thing you're ever going to add to it is water. Okay? Lastly, you really, I don't remember if I talked about this. You do not want to stick this down into the battery, pull it up, and sit here looking at it. Okay? Notice where it's going to squirt and dribble down, okay? Don't want to do that. Leave it down in the battery. Bend over, look down, get close. Now, if I'm looking at it from an angle, I'm probably going to get a false reading. So you're going to have to get to where it's level. The other thing that's going to tend to happen because of capillary action is, and particularly the manometer or the hydrometers that I've got are they're a little bit smaller than this. As you float the boat up, it'll tend to get some little bubbles stuck to it. Okay, well those bubbles are going to throw it off. They're going to add a little bit of lift. So you may have to tap it just a little bit to get the bubbles to shake free. And then once you've got it free floating, then read it. The other thing is those hydrometers, they've got a little cork in the bottom and a little cork in the top so that it doesn't go up into here. So if you've got it so filled up that the manometer is pegged up against the cork here, or not, I keep saying manometer, that the hydrometer is pegged up on the top, it's also going to be a false reading. You've got to have the fluid level somewhere in the middle so that the thing, the bulb inside is truly floating. Okay? That makes sense to everyone. All right. So what we're going to do is we'll go out there. There's a power station, and there's 5 batteries, 5 power supplies, 5 voltmeters, and 5 hydrometers sitting there. So you guys all need to be in groups of 5. And one person take notes. One person's going to read the 6 values, the hydrometer values of the battery in its current state. Maybe somebody else wants to take a voltmeter reading of the battery. Okay, if any of them need a little cleaning up, I might have a brush out there. And then once you've got everything good to go, the caps can go back in. They're vented caps. Then hook the battery charger up to them, and we're going to charge them at about 4 amps. Okay, the vented caps are pretty simple little guys. Let me show you one of those. So as you can see, this one has the little cap removed. There's a little lead weight in there. The little lead weight is connected to this little dongle with a rubber gasket there. So when it's sitting like this screwed in, it's straight open. It can't pressurize. Right? So a fully vented lead acid battery can't pressurize. If the battery gets laid on its side or upside down, then these guys will close. They don't completely stop. I mean, there's going to be a little bit of moisture oozing out of there, but a short period of on its side or inverted, probably the battery shouldn't leak profusely. Okay, that's the whole goal. But they should be open. One of the things is you pull the cap off, just make sure you can feel it rattle a little bit. If it rattles a little bit, it should be working. Of course, you can look right at it. Because they will gas and bubble and toil and trouble, you may get some fluid sitting in here. So when you go to pick that up and look at it, go, wow, and shake battery acid all over yourself. Okay, don't do that. Again, the way to do that is pull these up and just lay them on the battery. Okay, keep everything in the battery bench area, on top of the battery, or the hydrometer laid right next to the battery. Anything that touches acid, keep it down in that area. That way it's less likely to get to you. If in fact you do get anything on you, you think you saw a splat, to the sink, flush. If it's your eyes, I would still suggest to the sink, flush, because I have no idea what the water's gonna look like coming out of that eye wash station. A few times I've checked it, I would sooner put sewer water in my eyes than, that's just nasty.
Oh.
We've complained about it, and the district response is it's appropriate, it's approved. Like, okay. One more thing where I'm, you know, whenever OSHA comes by, say, hey, why don't you go wash your eyes there? But you know, in all truth, the other thing is, once you've done that, wash your hands. Okay, be somewhat rigorous around that. Did it just tie again? No, just let me hibernate. So yeah, be rigorous around washing your hands. Then, whoever does the data recording, you want to change up who does each. So each time you go out there to do some measuring, I want each of you to get a chance to get some hydrometer reading, to take a volt reading, to record notes, etc. You might want to, you know, at the end of the day, at least one or two people in the group take a picture of the data. So in case that person decides to stop attending, the rest of the group still has the data. Right? Okay, just make sure you share that just a little bit. Once we're done, and again, this is going to be 3 or 4 weeks. Once you're done with the reading, we'll come back in and start lecturing, and then come the break time, we'll maybe let it run past break. We'll come back from break, take another reading, lecture some more, and we'll just kind of keep doing that for the next few weeks until we can get the battery charged. Now, my understanding, I could be wrong, but my understanding, we have a holiday next week. Am I wrong? Is that correct?
President's Day.
No idea.
Holiday. Oh, I don't know about that. So what that is going to mean to us is what will probably happen is we're going to charge our batteries and then not do for a little while today, and then not do anything for a couple of weeks. So in all likelihood, what's going to happen is they're going to kind of self-discharge some. So I would expect to see in all your data, at the end of the day, the hydrometer readings are going to come up, the voltmeter readings are going to come up, and then 2 weeks from now, we're going to see everything, maybe not gone all the way back down, but it's settled back down some. And in fact, from week to week, we'd expect to see a little bit of that anyways. Normally what you're going to do with a lead acid battery like this, again, some of them may be pretty weak. Normally what you would do is charge it for 12 to 15 hours at say 2 to 4 amps.
Continuously?
Hmm?
Continuously?
Yeah, continuously at pretty low amp. I mean, I think they're 25 amp hour batteries. So 2 amps, that would be 12 and a half hours plus a little bit. Lead acid batteries, you can zap them with 40 or 50 amps, but it's not good for them. Okay, if you got a dead battery, you're in a car and you just need to get it started, you pull out the big Mongo battery car starter charger thing and let it rip. Throw it on there for 5 minutes and start the engine. It's not good for the alternator, it's not good for the battery. If you do that in an airplane, and I see it done a lot, I gotta ask the question, is that battery being non-operational in that it's discharged on the minimum equipment list to be discharged for operation of that airplane? Most little bitty airplanes don't have minimum equipment lists. So is it airworthy? If you take off with a battery that's most of the way dead and it's a battery operated system, by what authority does the pilot have to make the decision that the airplane is airworthy with a dead battery? Even though they're able to get the engine started and it'll charge the battery up after a fashion.
Not sure.
After it charges the battery up somewhat, at what point does the plane become airworthy? If it isn't airworthy. 25% charge, 75% charge? These are all questions that I don't think there's an answer to. My guess is the FAA, if they were sort of looking at an enforcement thing, they might sort of look askance and wonder what to do. I can tell you though, in a civil case, you absolutely know the lawyers would be all over that one.
Wouldn't it be like my truck had a problem discharging, and so I had to get a new battery. So wouldn't it be better to base it off how fast it discharges?
Not sure I'm completely understanding the question. Your battery was self-discharging in a relatively
Like,
short period of time?
No, because it was I would have to jump it every time because it was so old, you know. And then
Well,
I
it's
got
probably
another-
just internally shorting it. It was self-discharging in minutes. They normally self-discharge at like 4% per month for a lead acid battery. Pretty slow. Okay, but if it's got an internal short and it's dying, it's either internally discharging or it may not have any capacity left. So what used to be 100, you've got 4% left or 5% left of capacity. So it just, it's not gonna last very long.
Can you put a battery in hibernation if you drained it, and you cannot? Once the process starts.
Once the process starts, the clock starts ticking.
Okay.
I suppose if you had it super Mongo, completely, totally unilaterally, universally charged to the best of your ability, poured everything out, filled it full of pure water, drained it out, filled it full of, did that a few times, and then left it full of pure water, you might buy a little bit of time, but at the end of the day, whatever's in there, you're never ever going to be able to completely dry it out.
Mm-hmm.
So it's going to corrode. Just mere corrosion is going to occur.
Okay.
So battery manufacturers, they don't even. I mean, once you pour it, once you put the two together, the clock starts ticking. And in your case, had I been working on it, looking at the logbook records, I would say, "Oh my God, the battery's 8 years old." I already have a pretty good guess that the battery is part of the problem. Now, what I don't know is, did that older battery cause other problems? Or was the older battery sort of marginal, but another problem has now occurred, like the generator's gone bad or something else is going on that has now tipped the scale here as well. Oftentimes in a charging system situation fault, you often have more than one problem. I mean, we talked about this a little bit last week. What is a battery? Isn't it like a giant zinc plate that we use on a boat? Okay, it's a corroder. Its purpose is to corrode. And all the connections to it are going to be different metals. So all those dissimilar metal connections, they're going to be prone to corrosion. Okay, so we're going to go from lead peroxide to a lead post, maybe to a lead clamp, to a copper cable, out to maybe a brass stud, or, I mean, as you go along the entire chain of the circuit, you're going to, and of course, if you don't have a factory cable, you cut the end off and put one of those steel clamp things on there. You've added a couple of more different metals in there. It's just a recipe for bad connections, right? So batteries are one of those things that are kind of like, we don't treat it this way, but we should. They're kind of like oil. You actually need to get in there and do something pretty regularly. Should get in there and do something pretty regularly. And I'm sort of that mind. Every time you do an oil service, check the battery connections, clean them up. Clean any corrosion, any debris, clean the top of the battery up. Any crud collecting on there can be a path for the electrons to migrate in ways you don't want them to. All right, so groups of 5. I'm going to let you guys sort it out. So what are we? You should be able to get that figured out, get your measurements done, and maybe be back here by about a quarter after. So all the batteries are out there. Voltmeters are out there. Red goes to positive. Black goes to negative. Unless I plugged them in wrong, which I could do.